In this relatively brief video, we're just going to take a look at a few surfaces, and these surfaces are being used to highlight some of the things that we're going to be learning how to compute in the next video. And I'm going to go ahead and plot the first surface. You can see this surface has a lot of peaks and valleys, lots of high points, and then some low points here. So just again, to be clear on the orientation, there's our y-axis, there's our x-axis, and the z-axis there is that vertical axis going up. So you can see z equals 0 is right about here. So that this is kind of the xy plane isn't being shown, but essentially half of this surface is above the xy plane and half, well, of what we can see is below. And then above the xy plane, you can see some peaks, right? And these peaks, we're going to refer to them the same way we referred to peaks in Calc 1. We're going to refer to these as relative maximums or local maximums, because again, not on the overall surface, but if we are in this location, this kind of local region on our surface, then this is a high point. So there is no z value, right? If I just kind of focus in on this little portion right here, right? There is no z value that is larger than this peak right here. And then the same could be said on this portion over here that's colored slightly differently. Let me just rotate it like this. So again, here you could say that your z value has a relative or local maximum. And then on the flip side, you have minimum. So you can see kind of bottoms out here, and then similarly over here, you can kind of look through it. You can see that the z values are kind of minimized here. Not that these points do not represent the lowest point on the surface. Obviously, we have lower z values here, but again, if you focus just on this portion of the surface, then you can say here your z values are minimized. So the concept of minimums and maximums are very similar as they were for curves. It's just that now we have to develop a process for finding and classifying these high and low points on a surface. Now, the interesting thing when you go from 2 to 3D, not only can you have, now what's interesting, let me say this about these relative extrema, which is just the plural, maximums and minimums together. If we were to construct our tangent planes at either the high points or the low points, the tangent planes would be horizontal. So the tangent plane would be like a cap here, a ceiling kind of, and it would be horizontal, meaning it would be, well, let's just say it would be parallel to the xy plane. And similarly, if I were to construct the tangent plane at this point, again, it would be sort of a horizontal, or better yet, it would be a plane that will be parallel to the xy plane. And it kind of represents a situation where the surface peaks or bottoms out. Well, it turns out that there are some other things that can happen, or specifically one other thing that can happen that can cause your tangent planes to be parallel, but it doesn't have to be a min or a max. And that would be illustrated on a surface like this, right? So right in the middle, right, it's like there is kind of there's just at that particular point, it's like the surface is flat, but in one direction, right? For instance, if I start at that point and let's say I move in a direction that's parallel to the x-axis, my surface slopes upwards. So my z value will be increasing. Whereas if I were to walk, let me turn it around just a little bit like this. If I were to walk in a direction that's parallel to the y-axis, so like I'm walking towards you, right, as you watch this, the z values would be going down, right? So starting at that same point, it doesn't represent a peak, it doesn't represent a high or a low point, but something interesting is happening here, and this kind of point is referred to as a saddle point for obvious reasons, right? Because the surface at this location, it takes on the shape of a horse's saddle, right? Let's look at another quick surface here to really illustrate this. Let me turn it this way. If you notice, the surface again becomes very flat in this at this particular point, right? It seems very flat. And if I start at that point, and again, if I move in this direction, look, my z value is going up, 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 up. And then if I kind of come towards the screen this way, you can see the z value going down, right? And again, this is an example of a type of point that we refer to as a saddle point. And we're going to develop, or not really develop, we're just going to learn of a way that we can identify when this type of phenomena occurs on a surface. So not only are we interested in the peaks and the valleys, but we're also interested in these points that we refer as saddle points, right? So there you go. That's just a visualization of the things that we're going to be computing. And I know you can't wait to learn how to find these things. So hop on over to the next video and I'll explain exactly how you do it. See you then.